Okay, everyone, so you spent some time completing this column and completing this column, which led you to this column, and you were to do this on all 6 pages. I may or may not have put you in groups. It just sort of depends on where my thought process is at the time. But you had a lot of work to do, and if you did not complete that, you need to stop this immediately and complete it, because we're going to move ahead, okay? So what you're going to want to do now, we're going to leave this column blank because we kind of don't care about the bond angle. We just want to use it for space in case we need it for our drawings. Okay, so what we want to do is we want to determine if we have a polar bond, yes or no. Okay, and so this is an enormously important topic. So you're going to need to find your electronegativity chart and remind yourself whether you have polar bonds, yes or no. And I'm not going to reinvent the wheel in terms of reminding you about all of this, so I'm sorry. But go back to your notes, your lecture video, and remind yourself that what you're doing for polar bonds is you're going to take the number on your chart, subtract it from the other number on your chart. All numbers are positive. Okay, so it's the absolute value, x minus y or y minus x, the absolute value. All numbers are greater than 0. And our magic number is 0.4. So if we're equal to, less than or equal to 0.4, we're going to call that nonpolar. Greater than 0.4, we're going to call that polar. Okay, so I'm going to go through the ones we did together. Okay. Carbon hydrogen is always nonpolar. Nonpolar, 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 nonpolar. Okay? On this one, carbon hydrogen, carbon hydrogen, carbon hydrogen, not polar. However, carbon oxygen is polar. Okay? Polar because carbon is 2.5, oxygen is 3.5, so the difference is 1.0. 1.0 is greater than 0.4, okay? So what that means is it's polar, and the oxygen has the higher number, so this gets the partial negative, this gets the partial positive. So what we want to do is we want to come back to our drawing, partial negative, partial positive, okay? And then we have oxygen, hydrogen. Oxygen, hydrogen is also polar. Okay, oxygen is 3.5, hydrogen is 2.1. So the difference is 1.4. It is very, very polar. Okay, so partial negative, partial positive. So I'm going to take this and I'm going to put it back in my drawing. Partial positive. Okay, I'm going to come down to this one. We've already determined that oxygen, hydrogen is polar. Partial negative, partial positive, positive, positive. Okay? All right, so this is what you're going to do third. Do all the ones on this page, all the ones on this page. You're going to find polar bond, yes or no. Here we have nitrogen, oxygen. Nitrogen 3.0, oxygen 3.5, so the difference is 0.5. We're going to subtract these numbers. So it's polar, it's slightly polar. Polar, oxygen has the higher value, so it's partial negative, nitrogen's partial positive. So now I want to go back to my drawing over here. Negative, positive, negative. Okay? Next page. Polar bond, yes or no. Okay? Carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, carbon. Those are all going to be nonpolar. But carbon, chlorine, carbon, chlorine, carbon, hydrogen, carbon, carbon, nonpolar. But carbon, chlorine chlorine is very highly electronegative. Okay? 3.0, 2.5. The difference is 0.5. Okay? So what that means is that this is polar. The chlorine is the higher value. So partial negative, partial positive. And so what that means is back here on our drawing, chlorines all get partial negatives. Carbon gets partial positive. And over here on our isomer, let me scoot it over a little bit, negative, positive, negative, negative, positive. Okay? All right, next page. Anything that's an expanded octet, we are going to skip polar bonds, yes or no. Okay, so this is going to be polar bonds, yes or no. We're going to skip it for these because it's just too much. All right, and then so forth. All right, so you've got a lot to keep you busy. Okay, so your first task, again, you have to get the Lewis structures right, to get the electron geometry right, to get the molecular geometry right so you can draw it properly, to get the polar bonds right. Okay? All right, that then leads us to a polar molecule. Polar molecule. Do we have a net dipole? Okay, do we have a net dipole? And I think in the notes that I did for you, or maybe I did it for my 110 class, what we're looking for is, if we're thinking of our little man, our little decapitated Lego man. Okay, so Lego man is starting here. If he goes 2 steps forward, 2 steps backwards, he hasn't gone anywhere. He hasn't made any net progress, okay? But if our little guy goes 2 feet or 2 steps this way and then 2 steps that way, he started here, he ended there. Started in Illinois, ended in Kansas. Starting and ending in different places. That's what you're looking for. Okay, so refer to your notes, refer to your book, refer to T.A. Tyler, because I'm not going to reinvent the wheel on that. But what you're looking for is the easy ones. So for example, this one doesn't have any polar bonds. There's no polarity here. So this one, no net dipole. So this is a non-polar molecule. This one, on the other hand, has pluses that are down here. Okay, here's a plus, here's a plus. It has minuses that are up here. So your pluses are here, your minuses are up there. You have a net separation of charge. So you would say yes, net dipole, polar molecule. By the way, we can bleed over into this column because we're not going to talk about this. This one, you also have your polar bonds. You have positives down at the bottom, negatives up at the top. Okay, now your videos talk about vectors. We can add vectors if you wish. Vector, vector, tip to tail. But for simplicity, it's a lot easier for me to just show you, do you have your pluses in one place? Do you have your minuses in another? Okay, so your pluses are down here, your minuses are up here. So you would say yes, net dipole, polar molecule. Okay, so you're going to do this fourth. By the way, this one I'll call 1A. Okay, some have resonance and isomers, but most of them do not. So I can help you out there. I'm going to say no, 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 no. Okay, so I don't want you spinning your wheels on stuff that you don't need to worry about. Okay? All right, on this one's going to have an isomer. No, 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 no. Okay, so you have to figure out what the isomer is, all right? This one, all right, you've got your minuses down here, you have your plus up here. If you want to draw vectors and add your vectors tip to tail, you can certainly do it that way, okay? And so this one is yes, net dipole, yes, polar molecule, okay? This one's going to have isomers, no, 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 no. All right? And continue on. All right? No isomers, none, 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 none. That's the only one on this page. Okay, when you get to your expanded octet, you can skip this. We are not going to try to add vectors or look for a net dipole on expanded octets. Okay? No isomers or resonance on any of these either. All right, so that's a quick overview of this task, and I've tried to lead you along, but you can see it's a big, big task. Please devote plenty of time and do it in the order that I'm telling you. Okay, and with that, we've exceeded 10 minutes, so I'm going to shut this one off here. Good luck, and I'll give you some instructions on how to submit this or how you're going to earn your points for it.